Hello students, welcome to my YouTube channel. In this video lecture, we are going to continue solving the next 10 questions from point of no return, point of equal time chapter in Keith Williams General Navigation book. Let's start. Question 51. What is the distance to the point of safe endurance if aircraft has a true airspeed of 350 knots, endurance of 10 hours, and winds of 50 knots headwind on the outbound leg? So this is your point A, this is your point B. Here is your point of no return. Your aircraft is at point A, like this. So the true airspeed of your aircraft is 350 knots. True airspeed is 350 knots. Now on the outbound leg from A to B, you are getting a headwind component of 50 knots. A headwind component of 50 knots. What will be the ground speed on the outbound leg? The ground speed on the outbound leg will be 350 minus 50, 300 knots. Ground speed on the homebound leg will be 350 plus 50. This wind component will become a tailwind when you are flying homebound. So that will be 400 knots. Now we have to find the distance to the point of safe endurance. So distance to the point of safe endurance is endurance into outbound into homebound divided by outbound plus homebound. What is endurance? 10 hours. Outbound speed 300. Homebound speed 400. Divided by 300 plus 400. So that is 700. In the numerator we have 300 into 400 into 10. So 1200100 is equal to 1714 nautical miles. So correct answer is option alpha. 52. What is the time to the point of safe return if outbound speed is 375, homebound speed is 480, endurance is 9 hours 30 minutes? So let's find distance first. Distance is endurance into outbound into homebound divided by outbound plus homebound. So endurance is how much? 9 hours 30 minutes, so 9.5. Outbound speed 375, homebound speed 480 divided by 375 plus 480. 375 plus 480. So 375 plus 480 is 855. The numerator we have 9.5 into 375 into 480, 1710,123. So that is equal to distance to point of safe return is 2000 nautical miles. What is time to point of safe return? 2000 divided by outbound speed 375, which is equal to 5 hours 20 minutes. That is equal to 320 minutes. 320 minutes. So option delta. What is the distance from Q to the point of safe return for aircraft that was over Q at 1520 flying directly to R? Distance between them is 3120. True airspeed 450. Endurance 10 hours. Wind component on the outbound leg, headwind 80 knots. Wind component on the homebound leg, a tailwind of plus 75. So point A, point B, this is point of safe return. Here is your aircraft. So the true airspeed of your aircraft is 450. 450. Now, flying outbound, you're getting a headwind of 80 knots. You're getting a headwind of 80 knots. So the ground speed will be, outbound ground speed will be 450 minus 80, 370. Flying homebound, the ground speed will be what? Now flying homebound, you're getting a tailwind of plus 75. A tailwind of plus 75. So your ground speed will be TAS 450 plus tailwind 75, that is equal to 525 knots. So distance to point of no return equals to endurance into outbound speed into homebound speed divided by outbound plus homebound. What is endurance here? It is 10 hours. Outbound speed is 370. Homebound speed is 525 divided by 370 plus 525. So 370 plus 525 is 895. Numerator 10 into 370 into 525, 1942500. That is equal to 2170 nautical miles. So option Charlie. 54. What is the distance to Bravo from point of equal time? Total distance is 560, task is 200, outbound wind component headwind of 15 knots, homebound wind component a tailwind of 15 knots. So let's draw this point A, point B. This is your point of equal time or critical point. Here is your aircraft. Okay. So the true airspeed of your aircraft is 200 knots. Okay. True airspeed of your aircraft is 200 knots. Flying outbound, you are getting a headwind of minus 115. What will be the ground speed? Outbound ground speed will be 200 minus 15, that is 185. Flying homebound, you are getting a tailwind of 15 knots. So your homebound ground speed will be 215. Now, your point of equal time, distance to point of equal time or critical point is BH divided by O plus H. What is the total distance between them? 560. Homebound speed 215 divided by 215 plus 185. That is 400. In the numerator we have 560 into 215, 120400. So that is equal to 301 nautical miles. So distance to critical point is 301 nautical miles. That means this distance between A and critical point is 301. The total distance between A and B is 560. So what is the remaining distance between critical point and Bravo? 560 minus 301, 259. So correct answer is 259, option A. 55. Aircraft is flying at a task of 375 between two airports which are 500 miles apart. What is the distance from first airport to the point of equal time if headwind component is 60 knots? So point A again, point B. So task 375. Headwind component 60 knots. Now, what will be the outbound ground speed? Outbound ground speed will be TAS minus headwind, 375 minus 60, that is 315. What will be the homebound ground speed? TAS plus tailwind, so 375 plus 60, 435. So we have to find the distance to the point of equal time. The distance to the point of equal time will be THO plus H. What is the total distance? 500. So 500 into H, 435, divided by 435 plus 315, so 750. So 290 nautical miles. So option delta is the right answer. 56. How far can the airplane fly out from its base and return in 1 hour if its task is 280 knots, track is 090, winds are 045 at 50? So this is your point A, this is your point B, this is your point of no return. Now outbound track is 090, homebound track is 270, winds are 045 at 50 knots. Okay, that's 280. That's 280. What will be the outbound ground speed? What will be the homebound ground speed? Let's use CX3. So task is 280, outbound course is 90, winds are 45 at 50. So 280, 90, you get a ground speed of 242 knots. 242 knots. Next, flying homebound, same ground, same task 280, track 270, the ground speed will be 313. Your distance to point of safe return will be endurance into outbound into homebound divided by outbound plus homebound. Endurance is 1 hour, outbound speed 242, homebound speed 313, 242 plus 313. So 555, 75,746. So 136 nautical miles. 57. For a distance of 2000 miles, outbound speed 375, homebound speed 475, endurance 8 hours. What is the distance to the point of safe return? Distance to the point of safe return equals to endurance into outbound into homebound. So substitute the values. 850, 8 into 375 into 475. This gives you an answer of 1676 nautical miles. So option A. 58. Now, 2 points are separated by 1500. On flight between A and B, headwind is minus 20. On the return leg, it is a tailwind of plus 40. What distance from A is the point of equal time? So, you're flying from point A to point B. There is critical point in between. Flying outbound, there is a headwind of 20 knots. Flying homebound, there is a tailwind of 40 knots. So true airspeed is 490. So outbound ground speed is 490 minus 20, 470. Homebound ground speed is 490 plus 40, 530. So let's find out distance to critical point. DH O plus H. So 1500 into 530 divided by 530 plus 470. 1000. So 795. This gives you an answer of 795. So delta. Next, aeroplane is flying at a task of 250 knots on a track of 090, winds 045 at 50. How far can the aeroplane fly out and return in 1 hour? So again, point A, point B, this is your critical correction. This is your point of no return. Winds are coming from 045 at 50 knots. Track 090. So the true airspeed is 250. What will be the ground speed? Outbound and homebound use CX3. So task 250, outbound course 90, winds 45 at 50. So outbound ground speed 212. Homebound ground speed 250, course 270, homebound ground speed 283. I use distance to PNR formula. Distance to PNR equals to endurance into outbound into homebound divided by outbound plus homebound. So 1 hour into 212 into 283 divided by 212 plus 283. So 495 in the denominator. In the numerator you have 212 into 283, 59996. 121 nautical miles. The closest option is option A, 123. Next. What is the time from point A to the point of equal time? Let's use the formula for distance to point of equal time, dH O plus H. So 2500 into 485 divided by 485 plus 375. 860 in the denominator. Numerator 2500 into 485. 1212,500. That is equal to 1409 nautical miles. So time to critical point is distance 1410 divided by outbound speed 375. 3 hours 45 minutes multiplied by 60 2:25 minutes. So option Bravo is the closest option. So this concludes the lecture. I hope you have understood all the questions that I have answered in this video lecture. If you have any questions or need any more help, let me know in the comment box. Thank you for your time. Best of luck.